ChatGPT has emerged as a game changer in how we interact with information. Some people no longer rely on traditional search methods to find information on the internet. But many large language models, including ChatGPT, can suffer from the problem of hallucination, where they make up information that seems plausible, making it difficult for people to fully rely on them. So, how can we reduce hallucinations in these large language models? The answer lies in citing the sources of the information. PerplexityAI combines the search capabilities of Google with the conversational ability of ChatGPT by delivering accurate source-cited answers. This is an example of PerplexityAI response. I asked, "What is PerplexityAI?" and it showed the sources of information as well as answer. I was curious about how PerplexityAI works, so I reverse engineered it. The one on the right is a simple version I created. This is how the architecture would look like. First, it asks the user for a prompt. Then it searches the internet to find websites that match the user prompt. Next, it constructs a prompt to feed into a large language model. The large language model processes the prompt via API calls from providers such as OpenAI or Claude. And the large language model's answer is rendered and displayed in their user interface. Please note that there is no official open source implementation of PerplexityAI, so this is based on information I gathered online. The interesting part lies in how the prompt to the large language model is constructed using internet sources and how it renders information with citations. But before we delve into prompt construction, let's briefly discuss how a language model works. A language model takes a prompt and completes a sentence. Essentially, it's a probability model that predicts the next token based on the prompt. For example, given the prompt, "the best soccer player is," the language model outputs a probability distribution of the next token. Then, a token is selected among its probability distributions, which in this case is Messi. Then, the predicted token is appended to the sentence to predict the next token, and this process happens iteratively to complete the sentence. And that's how ChatGPT answers your questions. A large language model predicts the next token based on a given prompt, and you can modify your prompt to try controlling the output of the large language model. The prompt can be as long as it fits within the model's capacity. In prompt engineering, people add context to provide information to the model or instruct it on how to respond. For PerplexityAI, they use internet sources as context and instruct the LLM on how to format citations for these sources in its responses. This is a prompt I use to make the LLM respond like PerplexityAI. I have included a link to the complete prompt in the description of this video. After the large language model outputs an answer, the output needs to be rendered on the screen along with search results and citations. PerplexityAI has a well-designed user interface that shows search results and clickable citations that take you to the website. To make the response look like PerplexityAI, I'll let the large language model output in Markdown format and size the sentences with links. I also display the search result at the top in a plain list in Markdown, so the right on the screen is a rendered version of the Markdown output on the left. In summary, first, it asks the user for a prompt, then searches the internet for matching websites. It constructs a web prompt for a large language model, which processes it via API calls from providers such as OpenAI and Claude. Then, large language model's answer is then rendered and displayed in the user interface. In this video, I didn't explain too much about search engines, but check out the videos about TF-IDF and PageRank to learn more about how these search engines rank websites and match users' query to websites. The links to the videos are in the description. Finally, a simpler version of PerplexityAI for educational purposes is available in this GitHub repo. Please check it out for a more detailed implementation of what I explained in this video. Thank you for watching my video. See you soon in the next one.